Okay, so hopefully you've done these exercises and you're either checking your answers, or if you're stuck on something, you can figure it out with my help here. So again, the growth factor, just a reminder, is what we're calling B in this formula. And the percentages that we get is R. And the relationship between these is B equals 1 plus R is what we're trying to do. So this 57% is the R. If we want to actually do any math with it, you need to move the decimal place over 2 times to make it 0.57. And then the B is going to be 1 plus that, which is 1.57. Here, this R is going to be negative 0.103 after you write it as a decimal. The B should be 1 plus that, which is going to come out to be 0.897. So in other words, if you want to increase something by 57%, you multiply it by 1.57. If you want to decrease something by 10.3%, then you multiply it by 0.897. Okay, here if you move this decimal over 2 times, 1, 2, there we go. This is going to become 0.005 as a decimal. And the B is going to be 1 plus that, which is 1.005. So if you want to increase something by 0.5%, that's the same as multiplying it by 1.005. Okay, for this one, the A is 100, the B is 1.5, and remember, B should be the same thing as 1 plus R. So what is the R that you can add to 1 that gets you a result of 1.5? That would be, I'll write this as 100 times 1 plus 0.5. That R is 0.5. Also known as 50%. So this is an exponential function with a 50% growth rate. All right, here the A is 37.5, the B is 2, and remember B is always equal to 1 plus R. So what is the R there? 1 plus 1 is equal to 2. So in other words, this is 37.5 times 1 plus 1 to the power 2. And so the R is 1, also known as 100% growth rate. So increasing something by 100% is the same as multiplying it by 2. All right, here we have 0.4. So the A is straightforward, that's 100. The B is kind of straightforward, that's going to be 0.40. And that should be equal to 1 plus R. So you can solve this equation to get the R. You should get R is negative 0.6. So you could also write this as 100 times 1 minus 0.6 to the power t. So that's also a negative 60% growth rate. Or you can call it a decay rate if you want. All right, so exercise 4, we're kind of going the other way this time. This time they're giving us the real life description, and we want to try to describe it with some exponents. with an exponential expression. So they're giving us that the population starts at 20,000. So the starting amount, if you need to go back here and review it, the initial value is always A. So this is giving you A here is 20,000. And it's saying it's growing by a certain percent each day. The percent that it grows by is R, which is 60%. If you write that as a decimal, it's 0.60. So if you're going to write this as P of t equals A times 1 plus R to the t, and I'm using 1 plus R to the t because it's giving you R, that here is going to be 20,000 times 1 plus 0.60 to the t. You could also write it as 20,000 times 1.6 to the power t. Either of those are fine. Okay, now for B here, we have $1,000 investment and it's decreasing by 11.3% each year. So they're saying it starts at $1,000, so that's the A, and this is saying it's decreasing, so we want to use a negative number for R. So negative 0.113 represents negative 11.3%. So we're going to say, let's call it V of t equals 1,000 times 1 minus 0.113 to the power t. And you could write it like that, or you could also write it as 1 minus 0.113 should be the same thing as 0.887 to the power t. Like so. Alright, so here we have a radioactive sample that begins at 20 milligrams, so that's your initial value. And if it decays by 24%, that means R is negative 0.24. So we could write this as f of t. By the way, it doesn't matter what you use for the name of your function. You could just say y equals if you want. It doesn't really matter. That's whatever you feel like. I'm just using P for population and V for value and F because I don't know what else to call this. So f of t starts at 20 milligrams. So that's the A. And then the 1 plus R is going to be 1 plus negative 0.24 to the power t. So 1 minus 0.24 is the same thing as f of t equals 20 times 0.76 to the power t. So in other words, decreasing what you have by 24% every hour is the same as multiplying what you have by 76% every hour. All right, so good work on those exercises. Up next, we have some examples. We're going to do some more comparing linear functions and exponential functions in the next video.